Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. When we think of diamonds, we often think of the glittering gems in jewelry stores, symbols of luxury and eternal commitment. However, to a geoscientist, a diamond is far more than a decorative stone. It is a time capsule, a microscopic vault that holds the secrets of our planet's deepest history. These gems are born in the crushing depths of the Earth's mantle, at least 150 kilometers below the surface, where temperatures soar and pressures are immense. But the most fascinating thing about diamonds isn't their hardness or their sparkle, it's their origin. Recent research has confirmed that some diamonds are made from recycled carbon that once belonged to the air, the oceans, and even ancient life forms. This is the concept of the diamond barometer, a geological record that allows us to trace the ghosts of ancient atmospheres that have been trapped beneath the crust for billions of years. To understand how an atmosphere ends up inside a diamond, we must first look at the grand machinery of plate tectonics. Our planet is unique because its surface is constantly being recycled. Through a process called subduction, oceanic plates, heavy with sediment, organic matter, and carbonate minerals, are forced downward into the mantle. This carbon-rich material doesn't just disappear, it embarks on a journey into the deep interior. As these plates descend, they carry with them the chemical signature of the era in which they were formed. The carbon in these rocks might have once been part of a prehistoric forest, a shell of a marine organism, or even carbon dioxide floating in a sky that existed long before the dinosaurs ever walked the earth. As this surface carbon reaches the high-pressure environment of the mantle, it undergoes a radical transformation. Under intense heat, the carbon atoms rearrange themselves into the rigid, tetrahedral structure of a diamond. During this crystallization process, the diamond often captures tiny imperfections known as inclusions. These inclusions are often microscopic crystals of other minerals, but they can also be tiny pockets of fluid or gas. Because diamonds are the hardest known natural material, their internal structure is incredibly stable. They act like a chemical panic room, protecting these tiny samples from the extreme conditions surrounding them. They effectively freeze a moment in geological time, preventing the outside environment from altering the chemical data hidden inside. Scientists use a technique called isotopic analysis to read these records. Carbon exists in several forms, or isotopes, most notably carbon-12 and carbon-13. The ratio between these two isotopes acts like a fingerprint. Carbon that has been processed by biological life on the surface has a distinctly different ratio compared to the primordial carbon that has stayed in the mantle since the Earth was formed. When researchers find a diamond with a crustal, isotopic signature, they are looking at evidence of a cycle that has moved carbon from the sky, into the sea, through a living organism, down into the mantle, and back to the surface. It is a planetary-scale recycling program that takes millions, sometimes billions, of years to complete. This diamond barometer provides us with a window into the past that no other material can offer. By studying the chemistry of these deep Earth messengers, we can reconstruct the composition of the atmosphere from 2 or 3 billion years ago. We can determine how much oxygen was present, the temperature of the ancient oceans, and how the deep carbon cycle has regulated the Earth's climate over eons. It's a staggering thought. A diamond in a ring might contain carbon atoms that were once exhaled by a primitive microbe in an oxygen-poor world, or trapped in a storm that raged across a Hadean landscape before the continents even finished forming. Moreover, these diamonds help us understand the long-term habitability of our planet. The fact that Earth can store such vast amounts of carbon in its interior is one of the reasons our climate has remained relatively stable enough for life to flourish. Without this deep Earth trap, our atmosphere might have become overloaded with greenhouse gases, turning Earth into a scorching wasteland like Venus. The diamonds we find today are the results of rare, violent volcanic eruptions called kimberlite pipes, which act like high-speed elevators, bringing these deep treasures to the surface before they can be dissolved or transformed into graphite by the dropping pressure. In the end, every diamond tells a story not just of pressure and time, but of the connection between the highest reaches of our atmosphere and the darkest depths of our planet. They are the ultimate archives, proving that nothing on Earth is ever truly lost. It is simply waiting to be rediscovered in a different form. When we look into the heart of a diamond, we are looking at the ghost of a world that passed away billions of years ago, preserved in crystalline perfection for us to decode. For more incredible facts like this, don't forget to subscribe and turn on notifications.